Today we're going to talk about what causes inertia. What causes inertia? Personal gravity. Personal gravity particles cause inertia. If you've seen my other videos on the keyring and gravity, you know there are streams of particles going through the center of every single proton ring in your body, or all the atoms in your body. That is your personal gravity. And whenever you change speeds, those streams have to adjust. Now, if you're in a car and you're driving down the road, 60 mile an hour, and what happens when you hit the brakes? You hit the brakes, and you're pushed forward. Something behind you is pushing you forward. What is it? It's the gravity behind you. There's a gravity particle train wreck, and there's a void in front of you. And we're going to explain that at the molecular level. Now, if you're driving down the road in a car at 60 mile an hour, and you hit the accelerator, and you go faster, what happens? You're pushed backwards. The particles, what's happening? The particles here are pushing you backwards, and there's a void behind you. Now, to explain this in a little easier way, let's think of this as you're on a train track and you're traveling, and there's a bunch of cars in front of you, and none of the cars are hooked up. They're all just traveling at the same speed, and there's very low friction on the track, and there's a bunch of train cars behind you, and you're traveling at 60 mile an hour. Well, if you hit the brakes, what's going to happen? The cars behind you are going to go boom, 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 and they're going to bang on your back and push you. What's going to happen to the cars in front of you? There's going to be a void there, and there's going to be a gap. So what we have is a train wreck behind us and a gap in front of us. So now, readjust to the same thing again. You're traveling on a train track, cars in front of you, train cars behind you. But this time, you accelerate. So when you accelerate, what happens? You're going to bump into the cars in front of you. Boom, 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 boom. And they're going to slow you down. And as you accelerate, the cars behind you are going to be going slower, and there's going to be a void there. So there's a train wreck in front of you and a void behind you. All right. Now, if you can understand how that works on a train track, the same thing is happening at the particle level. It's a little bit different, but it's basically the same thing. So, if I'm traveling at 60 miles an hour, I have a stream of gravity particles behind me, and I have a stream of gravity particles in front of me. So, whenever I hit the brakes, the stream in front of me is adjusting to that speed of me slowing down. And what happens to the particles behind me? There's a void in front of me. What happens to the particles behind me? There's a train wreck. There's more of them colliding, so they put a pressure on me and push me forward. So now if I'm going 60 miles an hour, all the gravity streams have adjusted, and I accelerate, then I'm leaving the particles behind me. I'm going away from them. There's a void there, and then there's a train wreck of gravity particles in front of me. Boom, 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 boom. Just like the train cars. That's what's going on with inertia. Let me show you this now at the molecular level. This is a helium keyring atom. This is a gravity stream coming this way, and a gravity stream going this way. Just a front and a back. In real life, it's going to be three-dimensional. But to explain what we're doing here, we just need it in 2D. Now, if this is traveling at 60 miles an hour, all these streams have adjusted, and they're all adjusted to that speed, and you stop, what's going to happen? These particles are going to have a distance between them, and there's going to be a little bit of a void behind them. What's going to happen to these? These are going to bunch up. You're going to have several particles bunch up, and it's just like a train wreck. The particles behind, these gravity particles, are going to push on this atom until they readjust to the speed. Now, if you're doing the opposite thing, and that's why, like if you feel something pushing behind you, it's gravity particles. Whenever you hit the brakes in a car, Gravity particles are pushing you on your back. You can feel it. Next time you go in a car, hit the brakes. You can feel those gravity particles. Now, the next thing is, if you're traveling at 60 miles an hour and you accelerate, what's going to happen? The particles in front of you are going to bunch up. There's going to be a train wreck in front of you, and the particles behind you, there's going to be a void until they catch up to your new speed. So whenever you're in a car, hit the accelerator, and you will feel the particles in front of you pushing you backwards. It's gravity particles. It's your personal gravity particles at this level that push in front of you. Just like the train wreck. No different. And that's it. Now you know the particle that causes inertia. It's personal gravity. It's that easy. Whenever you're in your car and you hit the accelerator and you're pushed back, now you know it's your personal gravity particles pushing you back. And if you're in your car and you hit your brakes and you're pushed forward, you now know that it's the personal gravity particles pushing your back and pushing you forward. It's that easy. Just remember, physics and chemistry are easy with the correct geometry.